assignment constraint. For example, a user in particular user set cannot be assigned to 2 roles in particular role set. If you have this, you are associating set of intervals indicated by IP, which is periodic time expression as we use in the earlier constraint forms. That can be attributed to 3 different forms of semantics. The weak form is at any instant in that particular set of intervals, if a user is assigned to a particular role in R, at that instant he cannot be assigned to another role. So we're not saying that he cannot be assigned to another role within the same role set at another time instant. It's only concurrent assignment that is not allowed. Strong form is if you have IP, which is basically a recurring set of intervals, we're saying that if there is an instant in which a user is assigned to a role, for no other instant in that interval, he can be assigned to another role in that particular role set. So it applies to the whole interval, each of the intervals in IP. Still more form is extended strong form, that is if a user has been assigned to a particular role at no time instant at all throughout the set of intervals in IP, he can be assigned to another role. Okay, I guess I have to fast forward. We also address minimality and design consideration. Basically, the purpose is we have introduced so many constraints so that we could capture very fine-grained policy specification. And is it really useful? So the issue we addressed was, is there a minimal model that can express the same policies that the full set of constraints can be used to model? And that brings in the issue of clarity of semantics versus complexity of specification, essentially usability aspect of the model. And we try to address this by trying to do some complexity analysis in terms of how many roles are needed, how many assignments are needed, how many temporal constraints are to be handled, because handling temporal constraint is a significant task, and what is the hierarchy, complexity of hierarchy structure, because that also adds some processing time. And we use this notion of activity equivalence. If C1 and C2 are 2 configurations, which has user set, role set, permission set, and role hierarchy as defined, as well as a set of constraints to enforce particular policy, you could represent the same thing in 2 different configurations of this tuple. That is, you have C1 and C2. They are said to be A equivalent if a particular user can acquire a particular permission in C1 if and only if he can do the same thing in another configuration. So they are essentially equivalent. And by using this notion, we have created this family of A equivalent models where GTRBAC 2 represents the basic, the complete set of constraints that we can specify. And at level 1, we remove one particular type of constraint. And level 0 is basically we have constraint only on role enabling. We don't have temporal constraint on assignments of user to role and role to permission and so forth. And we see that there are alternative representation because of A equivalence relations among different configurations that we can employ. And they have trade-offs in terms of how many roles are needed and so forth. So essentially, here's a quick example. If you have the first one on the left top, it specifies temporal constraint on user to role assignment. You can express the same thing by transferring the temporal constraint on roles, but you are creating more roles, but you are avoiding user to role assignment constraints. And similarly, you can have another alternative representation where you create based on those temporal periodic time expression, distinct set of expressions shown here, P triple dash and so forth, which are disjoint. So roles here on the third diagram is enabling time periodic temporal constraints which are distinct from each other. So these have different trade-offs based on the figures, the different parameters that we saw. So this is just to point out that with some attributes like time introduced, it's a significant issue when it comes to usability. So I guess I'll forward to, we also have XML-RBAC specification language developed, and it can specify almost all of the constraints that we have we can express using GTRBAC model. And here's a snapshot of XML policy sheet, the high-level view, which has different components that can be employed. We have a architecture which is actually mainly to be attributed to Rafay Bhatti, who is also I have been working with. He was mainly responsible for implementing this architecture. So I'll move to conclusion. Basically, we have role-based access control model, which is able to support very diverse set of access control policies. Time is a crucial requirement. With that, we try to capture in and develop GTRBAC model. So I think I can stop here. If you have questions, you can ask now.
How is the implementation of that going?
Implementation going?
Yes.
Yeah, we have implemented a prototype already. And one part we haven't included in this implementation is the complete set of SOD constraints. Because I just mentioned 6 categories, but each category has different number of constraints that you can express. So altogether, I think we have about 36 SOD constraint specification, which is a substantial work to implement. And that is one of the reasons we try to address the issue of expressiveness, minimality. Can we have a smaller set of constraints to express everything?
Okay.
Well, thank you very much.
Good job.
Yeah.
I guess you had a few